Okay, so we know how we can use transcription, how we can generate the reverse complementary sequences, etc. Now we will try to translate some sequence. So for that also, sorry, we need the same module bio.sec import sec. Next, we need to generate the mRNA first from a given sequence, right? Now suppose here is the messenger RNA. Okay, this sequence defines a mRNA. So we are storing this information in the messenger underscore RNA this in this variable. Okay, so how we can create a sequence in BioPython? So we need to use this syntax: capital S, small e, small q, within parentheses, within quotes, we need to write the sequence. Simple. Okay, now you can check that whether it is working or not, whether it is rightly stored. So you can just type this and you can print. So you can see that yes, it is printing the messenger error. So that means it is okay. Now you just want to translate this thing. Now, if you translate this thing, so one simple method, that is dot translate, just like transcription dot transcribe. Here the code is translate. So you can use this variable name dot translate. So this code will translate this mRNA and it will show you the amino acid sequences corresponding to this code. Okay, only using one line of code you can generate the amino acid sequences from this mRNA. And here it is also shown that why some star marks are present inside this amino acid sequences. So that defines the stop codon. So if you go to the uh, genetic code table and if you put this three letters of codons, so you will get that AUG starts with methionine and then GCC for alanine like this, and somewhere you will get the stop codon and in uh, amino acid code, single letter code that has been marked with star symbol. All right. Read out. Even you can use uh, this translate method to translate from the DNA itself. Okay, so the same code will run for generating the translated product from the DNA itself. So here we are using this mRNA as a starting input sequence. If we are giving the DNA sequence, the same code will run and that will find out that whether it is a DNA or RNA inside this program, and accordingly that internally it will generate the mRNA first, and from that mRNA it will translate this product. Okay, so translate means it is checking that whether it is DNA or RNA. So accordingly it will convert that thing, and then you will get the amino acid. Okay. Now there are multiple other options also to deal with this translated product. I'm not going to the details of this thing. So we are just giving the basic idea how we can handle these codes. in BioPython. Okay. Now, now the next thing is sequence annotation objects. How we can handle the sequences. Suppose I just wanted to show you some file first. You have already seen that thing, right? You have already seen that thing. Some FASTA file like this. Is it visible? This FASTA file.
Yes, sir.
So that starts with greater than symbol, then some accessor number, then the organism name, right? Then the description of that organism. Okay, and on the next slide, the sequence, actual sequence begins. And now, if you want to extract the information from such FASTA file, so what to do? Suppose there might be one single file, or there might be uh, one single file there might be thousands of sequences given, right? FASTA file. So suppose you want to extract the name of the sequences, the organism name of the sequence. So you can do it by in a normal Python program also, but if you use BioPython, so only one single command you can extract those sequences or those informations. So we will discuss about that thing. Okay. Okay. So for doing that, I hope you know how where from you can download this kind of sequences. From uh, can anyone tell me from where you can download such sequences? Suppose protein sequence.
From NCVI.
Yes, in NCBI, which module you will use? There are lots of options available in NCBI. So you will go to which site? So these are very basic bioinformatics questions. So have you seen the uh, NCBI site,
Yes,
like
sir.
this site NCBI? So here you will find that lots of different databases are available, right?
Genome database.
Genome database for protein sequence.
Nucleotide is also there, no?
Nucleotide is also there, but I am asking about the protein sequence. So if you look at the nucleotide sequence, obviously you are expecting that that will give you nucleotides directly, not the protein sequence, isn't it? So mm, you need to know where from you can get the protein sequence. So there is a database known as protein. So you can go to that sequence, right? Or you can go to the nucleotide sequence, and from there you can click on different links also. No problem with that. Okay. So if you click on this, if you are interested to search for any kind of protein, say for example, one small protein insulin, and you will get uh, lots of information regarding the insulin protein, and this is the number you can get the right hand side. Okay, but all these are protein, not the DNA. If you click on, you can see the description also 156 amino acid protein. Now, if you want to identify the human, obviously you can do it by filtering this thing. So these are all Homo sapiens. Now click on this. Yes, so you are searching for Homo sapiens only. So it is showing that insulin isoform 2 precursor Homo sapiens insulin Homo sapiens. So this is the one you want, right? So insulin Homo sapiens 110 amino acids. Others are also Homo sapiens insulin, but those are isoforms or some less amino acids are sequenced, partial sequence you will get. Okay, so you can take this out. You can click on this and you can download the FASTA file from here, and by default it is showing the GenBank file format, right? So GenBank file format. I wanted to show you because there are multiple file formats are available. One such is FASTA, which is commonly used, and other files for file format like GenBank is also used to store the data uh, in definite order, like low cost definition, accession, version. Okay, so there are multiple features available in GenBank file system file format. So if you are using GenBank file format, you can easily call these features or call these records. These are also termed as records. So we'll see in the next few slides or examples that how these records can be called using uh, BioPython command line. Okay, so and another thing is in RNA-seq, in RNA-seq technology, some files are generated, and those files, the first file which is generated in RNA-seq technology, that is termed as first Q file. Those are not same as FASTA file. It must be remembered that FASTA and FASTQ are not same. FASTQ file has the quality scores along with this sequence, nucleotide sequences. Okay, so there is a particular format of FASTQ. I will show you in the RNA-seq RNA-seq theory part also, that how these RNA-seq files are written. Okay, in FASTQ format. Anyway, so here we will concentrate with FASTA and GenBank format only. So first let look at the FASTA format example. Okay, so yeah, so yeah. So for that also you need one module that is termed as sec.io. Okay, so it's here, I think so. Yes. So this is the module name sec.io. Okay. From bio import sec.io. This will be the command. Next, you need to read that file, right? Suppose for first time you need to store your FASTA file from where you are running your code. That is the main thing you need to remember. Then uh, you need to write this command like sec.io dot read. So that means you are using the read option from this module dot read. Okay, and what file it will read is a file name. It is already stored in your computer. And what is the type of this file? FASTA. You need to define it after a comma. Obviously, if it is a GenBank file, So you need to mention GenBank here. That's all. Very easy. So file name and what type of file is. So two parameters it need to read the file. And this file will store now in this record. Okay. So that is the easiest thing. Now what you can do, you can print that what is in record now if you are writing this way. Okay. So you can see that all the records are now in this object. You can see that from here to here. This is the property of sec record object. Okay. So within the sec record, you can see that this is the sequence, this is the ID, this is the name, description, okay, and dbxref. So all these information are stored, right? Got it? Now easily you can you can find out only that ID part from it. If you write record.id, run it, it will extract the ID part from this. Good. So very easy. You don't need to write lots of lines from Python code. Only you need to know that how to read that file, how to store it in an object, and then how these features, this ID can be extracted with the help of this command. Okay. Similarly, you can extract the record.sec. Using this command, you can so you can identify this whole sequence. Okay, very easy. Now, if you want to identify the name, you will use record.name. Okay, so here it is, record name. You can use record.description. It will show you the whole description of this record. Okay, even you can use the len operator to identify the how many records are there. Okay, so there is no annotations available with this, so it is showing 0. Okay, anyway, so this is the first example with this file nc underscore 0058116.fna is the FASTA file. So similarly, you can use GenBank, and you can use the same code. Okay, these files are already in my computer. Okay, if you need to use any other file, so obviously you need to download this file first, and then you should keep it in your directory where from you are running this code, and then only it will run. So you can use GenBank, and then you can see that what is in the record if you want to check. So you can see that this kind of uh, records are there, and same as you can use record.id, record.sec, all this information you can get from here also, from GenBank data. Okay. Same output you will get if it is same file. Okay. So all these features are true for both this file type, uh, FASTA format or GenBank format. Okay. Is there any query till now?
So is this case sensitive that while you are writing gene bank or FASTA, that statement is that case sensitive? I mean, if we write the F in small or capital, does that make any difference? difference?
This one, faster. Probably so, because these are hard coded. Let me try if it is so. Yes, so it is hard coded. So FASTA should be lowercase. Okay. For this, when you are defining this thing, what is the type of this file? So you need to put it in small letter always. Okay, not capital letter.
Okay,
Capital
sir.
not run. Okay. So hope you have note that check.io, this module is very much important for sequence input and output. Sequence input and output. Here you are handling the file. Here you are handling the file and you want to input some sequence, right? So that's why you need to use uh, this module check.io, sequence input output. Okay. Now, okay. So another, I want to show another thing, that is first check the, for example, what's the, okay. Now look at this file. Now look at this file. Is it visible? A file which may contain more than one FASTA sequence, right? So which will start from greater than symbol. So here two simple sequences are taken, but it may be thousands or 10,000 sequences in one file. That may happen. That may be possible. Now, if you want to extract all this information, like the single example, so what we can do? Let's take some example. Okay. For that, you need to so for that you need to write this syntax first. From bio sec.sec.io import parts. From bio.sec record import sec record. From bio.sec import sec. So this we have already used, but these two are new. Okay, because this will require to handle such multiple FASTA sequences in a single file. Okay. Now, first of all, you need to this is a simple example of file handling. We know that how to open a text file in using this open syntax. So this information is now in all the information is now in uh, file this file handle, right? So next we need to parse this file into records object. So this is a this is a way how you can store the all information in an object. from a file, from a text file. So you are uh, instructing that this file is a FASTA file, okay, and you pass this all this information in the records object. Now next, what you can do, you can easily write using the for loop, that for record in records print record ID. Okay, to write this, you are getting only the records, right? The record ID. From that file, you are extracting the two IDs only. Similarly, you can extract the name, record name. Okay, you can see that this is one record name and second record name is this one. So by this way, you can play around and you can get all the information in that single file, right? Okay. Next, okay. The next with what left? Hmm. Okay, was the file Genbank file? Okay. Okay. The next one example I'm showing that you can extract the record features also. Okay. So how to do that? If we write, suppose we are taking this Genbank file format for this 5816 GB. That example I showed you back. So now we are extracting the 20th features only. Okay, so you can see that it is showing that in 20th column there is these informations are available. Okay, so we can change this and you will see that is the CDS feature. Okay, so there are lots of features available, okay, with this Genbank format, and you can one by one you can extract this only using dot features, this command. Okay, so these are some examples. Sorry. Okay, so I think today I should stop here because my throat is not permitting to continue. I can complete this thing the next class. Okay, not many things I will discuss. Only few things like blast and all. How the blast can be used using BioPython. Very basic idea. We'll discuss and we'll complete this session by blast using blast and clustal W. How the multiple sequence alignment can be done using BioPython. Okay, and